Hi guys, and welcome to another video. And in today's video lesson we're going to be looking at tree diagrams. The question that we're going to be looking at is from the February-March 2013 paper 3, and it reads as follows. The probability that it will rain on a given day is 63%. A child has a 12% chance of falling in dry weather and is 3 times as likely to fall in wet weather. Now, before we start this question, what are tree diagrams and what are they used for? Well, tree diagrams is a tool that we use to solve probability problems, and it will be problems involving 2 or more events. Now, we're going to be able to calculate the number of outcomes by multiplying the options in each event, which will lead us to the fundamental counting principle. One of the important things that we must also note in this particular section is that the probability of an event occurring plus the probability of it not occurring is going to equal to 1. Okay, so that's complementary events. So that's important for us to remember. In this question it says draw a tree diagram to represent all outcomes of the above information. So let's construct this tree diagram. So what does it say? The probability that it will rain on a given day is 63%. So therefore, we'll start off by saying the probability that it will rain, so R will be rain, and the probability that it will not rain. So R is for rain and R is for not rain. They tell us that it's going to be 63% that it may rain. So therefore, let's write it as a decimal. So that will be 0.63. So therefore, the probability that it will not rain will be 1 minus the probability that it will rain, which is 0.63, which is 0.37 or 37%. So 0.37. Let's continue. A child has a 12% chance of falling in dry weather and is 3 times as likely to fall in wet weather. So therefore, let us now continue. So therefore, now falling and not falling. Now let's look at this. So here we're going to fall in rainy weather and not falling in rainy weather. And here we'll say falling in when it's not raining, that's dry weather, and not falling in dry weather. So not raining means dry weather. All right, so falling, not falling, falling, and not falling. So let's look at that. What's given to us here? Child has a 12% chance of falling in dry weather. So NR is not raining, so that's dry weather. So he has a 12% chance of falling in dry weather. So this will be 0.12. So 12% is 0.12. Therefore, not falling will be 1 minus 0.12, which is equal to 0.88. Now let's read on. It says here that a child has a 12% chance of falling in dry weather and is 3 times as likely to fall in wet weather. So remember, rainy now is wet weather. So 3 times as likely to fall in wet weather. So now that's going to be 0.12. So 3 times likely will be times 3. So therefore, that's going to be 0.36. So therefore, this child will have a 36% chance of falling in rainy weather. Therefore, not falling will be 1 minus 0.36, which is equal to 0.64, which is a 64% chance of not falling. Now that's our tree diagram completed. So the number of outcomes, as I mentioned earlier, will be multiplied by the number of options in each event. So therefore, we have R for rainy and F for falling. So we can write R, F, R, NF. So that's rainy and not falling. And this is not raining, which is dry weather, and falling. Not raining, that's dry weather, and not falling. So that's completed now, our tree diagram with the number of possible outcomes. Now we can answer our questions. What is the probability that a child will not fall on any given day? So not falling. So let's look at that. So therefore, not falling is there, and also here, not falling. So we have to follow the tree diagram down to the root. So we're going to follow it from the branches and down to the root. There's a root down here. Okay, so let's write that down. So 3.2, the probability of not falling will equals to, so not falling, we're going to follow it down to the root, and the root is as follows. So we're going to follow this direction here. Remember, there's not falling. So we're going to go down here. So we have to multiply these branches as follows. So it's now going to be 0.63 times 0.64 plus also not falling is here, so we're going to follow it down to the root. It's going to be as follows: 0.37. So therefore, it will be 0.63 times 0.64 plus 0.37 times 0.88. 0.88. That's now equal to 0.7288. 0.7288, which means if we have to now multiply that by 100 to get the percentage, it actually means that the child has a 72.88% chance of not falling on any given day. Now let's go and answer question 3.3. In question 3.3, it says, what is the probability that a child will fall in dry weather? That a child will fall in dry weather. So let's go and look at that. So firstly, falling in dry weather. So falling in dry weather will be here. So remember, NR is for not raining, so that's dry weather. So the chance of falling in dry weather will be as follows. So falling when it's not raining, falling in dry weather. So it will be as follows. So we only have this particular option here. So we're going to follow this down to the root as follows. So therefore, falling in dry weather, the probability of falling in dry weather is going to equal to, we're going to follow this tree down to its root, and that's 0.37 times 0.12. Let's calculate that. 0.37 times 0.12, and that's equal to 0.0444. 0.0444. And if they asked us for a percentage, then we'll say times 100, and that's equal to 4.44% chance of falling in dry weather. That's how you answer a question on tree diagrams. If this video has helped you, don't forget to subscribe to my channel. You can also catch all the videos jrmaths.com, and I'll catch you in the next video.